This is the algebra and number practice exam. There's not much number, it's mainly algebra. First of all, there were a couple of errors in the actual original sheet, the one that I posted out to people by email. So I have fixed up the errors in here. So when I go through this, it should be all fine. First of all, it's very easy to do these ones from question number 1 to even down to 16. If you have a very good calculator, you've got a huge advantage in just entering everything in exactly as it appears on the page. So with a good calculator, all you would have to do is hit 8 plus minus 2 to get 6. Now there's not much of a point in that case to actually, or in going through all of this, but you can just check the answers. All these ones here, maybe I'll just show you number 6 here, negative 4 squared, so it's negative 4 times 4, negative 4 times negative 4, and the two negatives cancel out to give you positive 16, divided by negative 8. So you've got another negative there. Alright, so it'll be negative 2 as your answer because there's a negative on the 8 there. Some of these other ones here, well, 6 ninths minus 1 ninth, well, 6 minus 1 is 5. You could actually do it in your head effectively. Once again, it's foolproof though if you've got a good calculator. Okay. Same thing for these questions over here in numbers 11 to 16 here. What you should do is simply, wherever you see a letter, replace that letter with the number that letter is actually equal to, in this case 3 for A, but put brackets around it. Now it won't always make a difference, but in some cases it does make a difference. So you'll never make a mistake if you actually do that though. If you put brackets around whatever number is for that letter there, so I put 3 brackets around it for A, and then plus, there's plus there, and then instead of B I've written bracket, negative 3 and then close bracket. Alright, negative 4 and then close bracket I mean. So that's instead of the B value there. Alright, so then when you hit equals on the calculator you'll end up with minus 1. And you don't really have to show this working here. I've only written it in there just to show you what you enter into the calculator. Alright, so maybe just look at one more over here. A squared, so A is 3, so in brackets you've got 3 and then a squared. Right, so you've got to know how to do that on the calculator there. Minus 4, open bracket 8 minus, and then in brackets negative 4 because that's what B is. Alright, and notice that there's another bracket afterwards as well because you've got the brackets around the negative 4 and then you've got a bracket that's already there. It's already there anyway. So you've got a second bracket there that you have to put in at the end, and your answer should be negative 39 if you've entered it in. So just try it out, see if you get the same answers as that, and if you haven't then you're going to have to figure out what you've somehow entered it in wrong. Or you can do it by in your head as well, other ways of doing it, but just make sure you get the same answers. If not, then you have to go back to the calculator and do it that way. Alright, down to algebra, that's number. Now these ones here cannot really be done with the calculator, so it's not so much of an advantage anymore over here. Think of this as a caret plus another caret plus another caret. Okay, so in English, even in English we leave out the ones, we say a carrot or an apple or whatever. And so in algebra in the same way we leave out ones. So it's just caret plus caret plus caret, it's 3 carrots. Don't make the mistake of writing to the power of 3 at the end. That's a completely different rule, and you only do that when multiplication is the main operator, such as over here. So that brings us to number 18. We've got times as the main operator, and there is an invisible 1, well, there's an invisible 1 in front of that C as well, 1C, but it's also to the power of 1 as well. And we don't write 1s after as powers either. But if there was a power there, we would put a 1 there. And so it would be 1 plus another 1 plus another 1. The rule is that you add up the powers. So there are 3 1s, invisible 1s there above the C's there. So you add them up and you get C to the power of 3. Now for this one over here, the main operator is plus. So we do not change the powers at all. Main operator is times over here, we change the power. Over here, operator is plus. We do not change the powers. Don't make the mistake of going a squared like a lot of people end up doing and messing it up. You end up getting it wrong. Okay, main operator, plus or minus, don't change the powers at all. Okay, so what we do is we've got 3 apples plus 5 apples is 8 apples. Over here, we've got a C, 1 carrot plus 7 more carrots is 8 carrots. Don't forget about that one there. There's 1 there, even though it's missing 1, there's 1 of them. Alright, let's go back up to the top of the page here. Now this is called combining like terms. We've got the main operator as plus and minus, so we do not change the powers at all. Notice that there's no power change there. There's a B and there's a B there, but we don't make it B squared. That's because we've got plus and minus as the main operator. What you have to do is you look at the things that have the B's in them, and then after that you look at everything that has no letter in it. Okay, so let's look at the things that have B's in them to begin with. 8B minus 2B, including the symbol, the plus or minus, that comes before this term here, 2B. So we've got 8B minus 2B gives you 6B, so that's what you write down. And then you've got plus 9, the remaining numbers that do not have B in them are plus 9, and plus 10 gives you plus 19 altogether. Next one, number 22. 5b squared times 5. Now when the main operator is times like this here, we could change the power technically if there were some more b's, but in fact there's no extra b's. We've only got 2, b to the power of 2, and there's nothing else to combine with that, so we're just going to write b to the power of 2 down there. And the numbers that appear at the start, the larger numbers, not the powers but the other numbers such as that 5 and that 5, you multiply those together. Do not multiply the powers. Alright, when there's a multiplication symbol, it means you simply multiply those coefficients, those numbers that appear in front of the letters, or by itself sometimes as well. So 5 times 5 is 25, and then the b squared comes after that. Alright, something slightly different here. We've only got an 8 and there's nothing else to multiply it with, so we'll write down 8. We've got b to the power of 3 and we've got b to the power of 1. There's an invisible 1 there. So because times is the main operator, we add the powers. 3 plus 1 is 4, b to the power of 4. Okay, next one, number 24. Once again, you've got the coefficients of 9 and 4. Multiply them together to give you 36. And then we've got b to the power of 1 and b squared. And so we've got 1 and 2 added together gives us b to the power of 3. Okay, so we're adding the powers as an invisible 1 above that b right there, because times is the main operator. Alright, when times is the operator, we change the powers unless there's like this one over here where there was just one single power in there, you just leave it. But when there's several, like b and b squared, you've got to combine them and you've got to add those powers together, 1 and 2 to give you 3. Okay, looks the next one over here. We've got the coefficients, 6 times 10 gives you 60, and then b, and there's no other b to combine with it, so you can't add the powers together. The letters must be dealt with separately. You could either write down AB or BA, it wouldn't matter which way around. Doesn't really matter the order. Alright, So I like to write in alphabetical order though, but you still get it correct with 6 dBA. Alright, next one over here, CB. So what we've got is the same, well, this is a little bit different. We've got minus as the main operator. We're not going to change the powers. We're not going to add the powers together. Notice that there's a C there and there's a C there as well. So if even that was C to the power of 1, C to the power of 1, we're not going to make it C squared. No, because this is not times. The only time that you change those powers there is when the main operator is times, and it's not. It's minus. So what you do is you go 9 of these CBs minus 4 of these CBs will give you 5 CBs. Just a single B and a single C, just like in the original. All I've done is I've reversed it and made it BC instead of CB, but you could keep it as CB if you wanted to. It would be perfectly correct as 5 CB. Next bit over here, we've got the two coefficients, number 27. 2 times 4 will give you 8. And because times is the main operator, we're going to add the powers. So let's look at B first. Write down B. You could do C first if you wanted to, but we're going to write down B first here, alphabetical order. And there's a power of 2, and there's also a power of 1. It's missing the power there. So it's actually a 1, and so you add the powers and make it, adding the powers because of the multiplication as the main operator. So you got 2 plus 1 there will give you B to the power 3. And then C squared, well, you've got to write down C squared because there's no other C to change it anyway. You're going to have to just write it in. Alright, next one. We've got plus and minus as the main operator. So we are not going to change the powers. We're going to look at 3 of these BC squareds minus 5 of these BC squared. It's like an object. Think of BC squared as some kind of object, some kind of thing. This thing which is a BC squared. Well, there's 3 of those things, and you're getting rid of 5 of those things. You should end up with negative 2 of those things. In other words, you've had 3, and then you lost 5, or in fact you're owing something as well. Maybe you lost somebody else's as well as your own. You're 3 and then you've lost 2 more and you owe 2 of them. Anyway, you're in the negatives here. Negative 2 BC squared. Alright, and then this plus 4 has to be by itself because that doesn't have any letters after it. You've got to deal with it separately. So it's just plus 4. Next bit here, times is the main operator in number 29. So we look at the powers. Write down the B first and look at the powers. They are 2 and 3, add them together and we get 5. Alright, next bit here, division. Now division is the opposite of multiplication. Although with multiplication, when multiplication is the main operator, times there, we add the powers 2 and 3 to get 5. We're going to subtract the powers. Division, you subtract the powers. Don't make a mistake of dividing these powers. A lot of people will make that mistake. They'll think that you've got to make that 6 divided by 2 gives us 3. No, you'll get it totally wrong if you do that. Don't make that mistake, please. We've got division as a main operator. We simply subtract the powers. 6 minus 2 to get C to the power of 4. Next one over here. Now this is a totally different thing. Another rule that you have to remember. Okay, let's just recap some of the rules here. Plus and minus, when you've got plus and minus, you do not change the powers at all. When you've got times as the main operator, you change the powers. In fact, unless there's one by itself like the C squared, but very often you change the powers if they're repeated, like a B there and 2B, and you add those powers together. Alright, and then for division, you subtract the powers. But over here we've got power of power. The main operator is in fact powers here. We've got to the power of 2 and then to the power of 4. Okay, what you have to do is you have to actually apply this 4 to the negative, and then to the 3, and then to the 2. Alright? Now let's go through them one at a time. If we've got to the power of 4 and you've got negative, well, there's going to be 4 of those. There's going to be negative, 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 negative. In fact, 2 of them will cancel, first 2 will cancel, second 2 will cancel. You end up with positive. Alright, so that's why I haven't got any negative in here. It's just positive, positive answer. Then we've got 3, and you've got to apply that to the power of 4 to that 3. So it's 3 to the power of 4. In fact, 3 times 3 times 3 times 3, which is 3 times 3 is 9, times 3 again is 27, times 3 again is 81. So that's where we get the 81 from. And now here's the other rule. But here's a completely different rule that you must remember. Power of powers mean you times the powers. Alright, remember, times as the main operator means you add the powers to get 5. Powers as the main operator means you multiply or times those powers. Don't add them. 2 times 4 will give you 8. So it's a different rule. Don't get those rules mixed up either. Next one, number 32. Coefficients 4 and 6. We're timesing them. So we've got 24. But then when you look at the powers of the letters, we're not going to times them, even though times is the main operator. We're going to add those powers together. So if we want to, let's start with the b, so write down b, and let's have a look at the powers of b. We've got b to the power of 2 and b to the power of 7. Adding them together we get b to the power of 9. And with a c, we've got c to the power of 1, invisible 1, and c to the power of 4. Adding them together we get c to the power of 5. Okay, division. We've got, first of all, you can divide the coefficients, and just like over here we could multiply those coefficients. The 4 times the 6 gave us 24, so it was fine, there's nothing wrong in that. But over here we've got division, and we simply do divide. 16 divided by 4 to give us 4, but don't do the same with the powers. Subtract the powers. So if we look at the b squared here, b to the power of 8 here, and then there's b to the power of 3 here. Well, we've got subtracting the powers, we've got 8 there minus 3 there gives us b to the power of 5. And when you see something that is the same, like c squared divided by c squared, they cancel out. It's like cancelling out on fractions. You're getting rid of a c squared, you're getting rid of a c squared from here, from there. Well, when you're dividing or on fractions, if you've got two things the same, you can just cross them out. There's no c squared there anymore. Expand and simplify. 3, we've got to multiply 3 on the outside by everything in the inside. So 3 times c gives us 3c. 3 times 8 gives us 24. And there's a plus in the middle, so plus 24. Next one, number 35. So b times b is b squared, minus in the middle, so write down minus, and then b times 4 is 4b. Next one, 5b times b will give you 5b squared, and 5b times 5 will give you 25. The coefficients at 5 and the 5 will give you 25, and then there's a b in there as well. If you ignore that b, we've got 5b times 5, you'll have a single b, won't you? Whereas when you ignore that 5, you just look at this here, 5b times b, there's 2 b's in there, right? So that's where you get the b squared. Alright, so that's what you should have there. Next bit over here, 3b squared times 4, multiply the coefficients, 3 times 4 is 12, and then b squared, so you write down b squared, and then 3b squared, you've got a plus in there of course, 3b squared times 6bc, a little bit complicated. Well, first coefficients, the 3 times the 6 will give us the 18. Look at the b's, we've got, remember we're multiplying here, 3, so we're using the multiplication rule of course. There's times, alright, don't get mixed up. Sorry, there's plus in there. Don't get mixed up though. Okay, the reason why we're not using this plus as our main operator is that's inside the brackets. Alright, in fact the main operator is a times in here. This is 3b squared times, and it's times everything inside the brackets. So because that is times by everything inside the brackets, times actually is our main operator here. We've got 3b squared times 6bc. Got your 18, and then the power of b is 2, and there's another power here, b to the power of 1, so it'll give you b to the power of 3 when you add the powers of b together. So that's where you get that. And then there's also a c by itself, so we've got to add that on as well. There's a c on the end there. Alright, next one, 38. Alright, easiest way to do this is if those two letters are the same, you've got to write down b squared. Okay, then we look at the other two numbers that are in there. Plus 2 plus 5 gives you plus 7. But b, you've got to write down a b. Alright, a lot of people make this mistake and they think, okay, we'll do plus 7 and then we'll do plus 10. Alright, well that'd be plus 17 mind you anyway. Don't leave out the b though. It's got to be b squared plus 7b, or it could be x's if you had x's in there. X squared plus 7x if it was x. And then you'd have plus 10 at the end. So notice that we're going plus 2 plus 5 to give us plus 7, followed by a letter, followed by these two here multiplied to give us. So plus 2 times plus 5 gives us plus 10. Next one. Now when we've got two letters the same, and then we've got plus a number and then minus that same number, what happens is when we combine those together by adding and subtracting, we get 0. So it's actually 0c in the middle. Notice we've got 7b in the middle here when we added the 2 and the 5 to give us 7b. But over here we would have 0. We'd have plus 4 minus 4 gives you 0. 0c, but you don't write it in. That's why there's nothing in there, right? There's no c value in there. It's just, yeah, you've got the c squared, c times c, and you've got the last bit here, plus 4 times minus 4 gives you minus 16. Next one, so we've got f and f, so f squared plus 5 minus 6 gives you negative 1, and there's an f, so negative 1f. Notice that I don't write in the 1. 1s don't get written down in algebra, so negative 1f will become negative f. And then we've got plus 5 times minus 6 gives you minus 30. Alright, next bit over here. 2b squared. Now this is actually quite complicated here. You should use the FOIL technique really. So FOIL means first. Let's start with first. So first for the f in FOIL. Outside, inside, last. First one is first. Okay, first. So the first part just after the brackets there, and then the first one over here as well, 3a. So if we've got 2b squared times 3a, we will end up with 6, and then there's an a in there. So write down a. You could do it in a different order. You could do the b's first if you wanted to, but there's b squared. Don't make the mistake of putting a squared on the a. Well, you can't do that. A doesn't have anything on it. B has something on it. You've got to keep it on it. Keep that b. Keep a squared on the b. Okay, so that's how we get that there. Next bit, the outside. So 2b squared and minus 6 on the outside as well. So 2 times minus 6 gives us minus 12. And then we've got the b squared as part of that outside as well. There's nothing else over here, so just write down b squared. And then the inside, negative a and then 3a. It's right on the inside of everything there. So include the negative sign there, and make sure you don't forget it. So minus a and then another a. So it's going to give you the a squared. But there's also a minus and a 3 there as well. So minus 3a squared. And then we've got L for last, FOIL. So last, it's easy, mnemonic there, FOIL, try to remember. So we've got last, so this is the last one just before the closed bracket, and the last one over here just before that closed bracket. So we've got negative a times negative 6 gives you plus 6a. Okay, so there's an a in there. The two negatives have to be considered, and they multiply together to cancel out. Two negatives cancel when you're multiplying. So you get plus. Alright, next one over here. The 4 gets combined with the b to give you 4b. the 4 gets multiplied with the plus 5, you got a plus, and then 20. So 4 times 5 is a 20 there. Alright, next one. Negative 3 times b is minus 3b. And then minus 3 times minus 4. Now, some people might think, okay, minus 12. But that's a common error. Don't make that error, please. We've got negative 3. You've got to include that negative there. And there's another negative here. So it's times, remember. And when you're multiplying, two negatives together, multiplying, the two negatives cancel out to give us a plus, plus 12. Right. Now these can be combined together as well. You look at the 4b and the minus 3b will give you just a single b. It's like having 4 bananas, losing 3 bananas will give you just a single banana. Alright, don't change the powers, because over here, in this line at least anyway, plus and minus are the main operators. Alright, so in that case you cannot change the power. Do not make that b squared. There's a b and there's a b, but don't make it b squared, because plus and minus are the main operators there. And you don't change the powers when plus and minus are the main operators. Now the 20 plus 20 and plus 12, you've got to combine those together separately as plus 32. Because they don't have a b in it, you can only combine the b's together, and then the other things get combined separately apart from that. Alright, next one. Number 43. So factorization is the opposite of expansion. Notice over here we had expansion here, so 3 times c, 3c, and then 3 times 8, 24. Right, now the opposite of that, what we're going to do is just have a look at my answer to begin with, and notice that if I expanded this I'd get 2b. Okay, I think I've fixed up everything except this one thing. I was trying to look for all the errors that I had in there. A little bit of an error I've left out, so hopefully it's the only one that I left out. There should be a 2 in there. Okay, so that should have a 2 on the outside and then 2 on the inside as well. Guess why? Because 2 times 2b is going to give us 4b. How do I get that 2 on the outside, mind you? That is the number, the highest number that we can use to divide both 4b and 14. So we divided 4b by 2 to give us, divided by 2 to give us 2. So 2, just look at the 4 by the way, not the b. So 4 divided by 2 is the highest number you can divide the 4 by and the 14 by. And so we get 2. And also you can divide this one here by 2 as well. Now what else do you need? You need 2b in here. I've left out a 2, and because that will multiply to give us 4b, and also a 7, because 7 times 2 will give you 14, and the plus is obviously there as well. So it took a while to explain that, so it's because there's a bit of an error in there, that's why, to make sure you understand that properly. Okay, now it's the only one probably with an error, I hope. We've got number 44, x, so we've got x squared. Now notice here that there's an x there and then there's an x squared here. When that occurs, you've got a common x value. So although you can't divide everything by a common number, there is a common x. So that x is common, so it goes on the outside of the brackets. Then inside the brackets we have everything else that is needed in order to make up the rest of it. So what we've got to do is we've got an x on the outside, you've got to put x in the inside as well, because x times x will give us x squared. And then the minus goes in there because it's there. And then we've got to have 16, because 16 times x gives us 16x, so we needed that 16 there. Next one, number 45, we've got now the number that can divide both 4 and 10, the highest number that can divide 4 and 10 is, we call it a highest common factor by the way, highest common factor is 2. Divide 4 by 2 and divide 10 by 2, so we write down a 2. And then also there's a common letter, notice that there's an x there, x there. Okay, so what we're going to do is we're going to write down x in there as well on the outside of the brackets, once again very similar to what we did over here. The y is not common, cannot use that on the outside of the bracket because it's not common to both expressions here and here. Alright, so what we'll do is inside the brackets we're going to have everything else that is needed to make up this expression here. You need 2 more x's here because 2x times 2x gives you 4x squared. And then you've got plus, so the plus there, and you need a 5y. 5y times, well, 2x times 5y will give you 10xy. Alright, so that's what we needed in there in order to make it work. Right, next one. We've got x squared plus 6x plus 8. Right, we need to look for 2 numbers that will multiply together to give us plus 8. What we need to do here is we need to find 2 numbers that will add together to give us plus 6 and multiply to give us plus 8. So the only 2 numbers that we can think of are 2 and 4. So you could have 8 times 1, which would give us 8, but they don't add together to give us plus 6. But 2 and 4 do. They multiply to give us 2 and 4 there, multiply to give us the final number plus 8, and they also add together to give us plus 6. So this is what you write down. You write down x plus 2 in brackets and then x plus 4 in brackets. Alright, next one over here. We're looking for 2 numbers that will add together to give us minus 6 and will multiply to give us minus 7. Well, the easiest one would be minus 7, because you can only have 1 times 7, and one of them has to be negative because you've got a negative answer, negative 7. So you're going to have plus 1 minus 7 or plus 7 minus 1. Which way around are we going to do it? Well, they have to add together to be, add or subtract together to be minus 6. So if you had plus 1 minus 7, you end up with minus 6. If you did it the other way around, minus 1 plus 7, you would not. You get actually a different answer. You get plus 6 instead, and we don't want that. So it's got to be plus 1 minus 7 in that order. Okay, next one over here, we've got 2 numbers we need that will add or subtract together to give us minus 7 and will multiply together to give us plus 12. So the only 2 numbers are minus 3 and minus 4. You know that 2 and 6 will multiply together to give us 12, but they will not add or subtract to give us minus 7. So it has to be minus 3 and minus 4. Notice if you started with minus 3 and then you went down 4 more, you would end up with minus 7. And when you multiply them together, notice that this is a plus here, but we used minuses. Well, how on earth did we get a plus from all of these minuses here? Well, they actually it's minus 3 times minus 4. We've got to multiply them together to get us plus 12. So 2 negatives multiplied together will become a positive 12. Next one over here is quite difficult. Use the FOIL technique here. There are lots of ways of doing it. Other teachers have different ways of explaining this and doing this. I like to use the FOIL technique of just guess and check to see if it works. You can use it. You're allowed to use guess and check in these cases over here when you're factorizing here. What you can do is just look for 2. Well, first of all, we need 2x squared. Now normally it would be just x squared by itself, like over here, and so it's x and then x, because x times x is x squared. Well, 2x times x actually gives us 2x squared, and there's no other numbers that you can use to get 2x squared, so that's what we're going to have to stick with, 2x, and then on the other brackets x. But you've got to look for the other numbers. How did I get this plus 3 and minus 2? Well, 2 numbers that will multiply to give us this minus 6 are plus 3 and minus 2, but they could have been something else. They could have been a 1 and a 6 or something like that. However, if you do a little bit of trial and error, you put a 6 in here and then a 1 over there, and then if you see if it works or not, you'll find that you won't end up getting this negative x or negative 1x that you really want here. Okay, so mind you, another way of doing this, if you wanted to, you could try -2 and then +3 on this side around the other way, but once again, that is really important to have it around in the right way, because this is not a symmetrical thing. You've got 2x here and only an x over here. You'll actually find that in most cases it ends up giving you a different answer for the middle value depending on the order that you put this +2 and -2, +3 and -2 in here. Depending on the order, when you work out the middle thing, it can be different. Okay, so you've got to try all different ways around, all different combinations. So -2 first and +3 as well, just to see which one actually works. So this one actually does work. If we look at the FOIL thing here, we've got the f for the first, which is 2x times x gives us 2x squared. The last is multiplying the last bit, which is +3 times -2, which will give us the -6 that we need there. Then we've got the O and the I. O for outside and I for inside, and those should combine together to give us this -1x. Now, how do we get this outside -4x? Well, you've got the 2x on the outside, and then -2 is also on the very outside of the whole expression here. So 2x times -2 gives you -4x, and then the inside is right in the middle. So you've got +3x, and that's 3x. So when you go -4x plus 3x, you end up with -1x, or just -x if you leave out the 1, which you should do. We don't have 1s in algebra. Okay, so I hope it explains that there. Next one over here, when we've got x squared, or any letter squared, minus another number that can be also square rooted, so we get the square root of 49. The easiest way to remember this is you simply write down x plus a number and x minus that same number, and that number that goes in there, the plus and the minus of it, is in fact the square root of this 49 here. So x plus 7 is the square root of 49, x minus 7. Now, one that's slightly more complicated, we've got to actually take the square root of both of these numbers here. So we take the square root of a 9 to give us a 3, and then we write down x. Okay, do you know the square root of x squared is in fact x? So we're actually taking the square root of everything here. Alright, so square root of x squared is x, so we just write down x there. And that's what we've done over here, square root of x, that's why we just wrote down x by itself. Alright, so square root of 9 gives us 3, square root of x squared gives us x, and then the square root of 64 gives us 8. And we have 3x plus 8, 3x minus 8. I could show you the reason why we do that, but you might want to try expanding it, and then maybe it will become evident to you why you do that. You'll find out that the middle term, something cancels out when you do that, but I won't need to really explain all of the details of it. Just try to remember the process and what you have to do in order to get that there, taking the square root of everything. Right, next one over here. Show you an easy way of doing this. Alright, so we have to get rid of this plus 3. And in order to get rid of this plus 3, we've got to subtract 3. And then we've got to subtract 3 from the other side as well. So plus 3 minus 3 cancels out, and you're just left with 4y. But then you've got to subtract 3 from 15 as well, and you end up with 12. Okay, easy way of doing this. Let's just think of an easier way. Alright, take this plus 3 and just subtract it from 15. Alright, so very easy. take the plus 3, get rid of it, subtract it from the other side. Okay, and then what we do is we can look 4 times 3 is 12, so y is 3. Now you really do have to actually show you're working for this. Alright, it says here, showing each step, should have at least one step of working. Now the reason why we want people to do this is that although in this case here you might be able to guess, 4 times 3 is 12 plus 3, 15, so it must be 3. Well, yeah, we can do that, but it's not good. There's a reason why you won't get full marks for this, because we want you to learn the algebraic technique, because what happens is these things get so complicated. Have a look at this one over here. I challenge you to try and figure out what C is there. Without, you probably wouldn't be able to guess and check that. Figure out what C is there, try a value for C, and see if you can figure out what C is by just guessing and checking it, seeing if it works. It's too complicated. That's why we've got to learn the rules for the easy ones first, so we can then advance and use the same technique that we've used for the easy stuff for the more difficult stuff over here. Alright? Okay, so let's have a look at this one over here. We've actually got to do bed mass backwards. Alright, when there's an equals in there, it's an equation, and we're moving stuff from one side of the equation to the other, we use bed mass backwards. We start with addition and subtraction. Alright, so then there's division over here we'll do last. So another way of looking at it is you get rid of the stuff that's further away from a letter first. So that minus 3 is further away from a letter, and we're trying to like unpeel an onion. Okay, so everything around the letter, around the B, which is the central part of the onion, needs to be removed and taken to the other side. First of all, we'll get rid of the outer layer of the onion, the minus 3. Take it onto the other side, it becomes plus 3, so you get a 5 on the other side. But then when you get rid of that minus 3, you've got just B over 8, right? Now that divided by 8, or over 8 divided by 8, the opposite of that is times, so we've got to get rid of it. We've got to do the opposite on the other side. So we get rid of it, we're left with a B, the inside of the onion. The other little bit gets taken away, divided by 8, and you multiply times 8 on the other side, 40. Alright, next step over here. We've got B plus 6 and 11 minus 5B. What you have to do is, now I've actually done combined two steps together here. What I have to add to this is that if there's two letters and the two letters are the same, and I hope they were the same, I think in the original thing I might have had A and I shouldn't have had A, I had to change it, which is a bit of a pain, but anyway, it's what it should be, really the same letter here. So what we can do is move the letters and everything that immediately surrounds the letter to the other side, to the left hand side, because we don't want to have two onions to unpeel. You've got to combine that, so you've got two, all the B's are combined together. So we want to put that on the left hand side. It's better to have a letter on the left hand side. So to get rid of that there, it's minus 5B, and we're going to make it plus 5B on the side over here. And so that becomes 6B. And then the minus 5B cancels out. And we've got this number here, plus 6, and we're going to get rid of that. We're going to do the opposite on the other side, and we're going to, there's a number by itself, and we want to get it onto the right hand side. So it becomes minus 6 on the right hand side, it becomes 5 on the right hand side. 11 minus 6 becomes 5. Right, so we get 6B equals 5. Now this is 6 times B, or B times 6. And you're multiplying by 6, so to get rid of that 6 we would have to divide by 6, or fraction over 6. Alright, so get rid of a 6 on the left hand side, put it onto the right hand side, and it becomes 5 over 6, 5/6. Alright, next one over here, number 55. This is just combining some of the skills that we've learned earlier on, putting it all together. This needs to be expanded first. We've got 5 times B becomes 5B. And then there's a minus in there, and then you've got 5 times 3 becomes minus 15 equals, and then we've got exactly whatever's there, 2B plus 4, and then 2B here, you take that over to the other side over here, to the left hand side, and you subtract that, and it becomes 3b. So we've got 3b, and then because we want the b's by themselves on the left hand side. Okay, so this 2b over here is on the right hand side. We don't want it there on the right hand side anymore. We've got to subtract, it's plus 2b, subtract 2b on this side, so we end up with 3b. Now, the minus 15 over here, well, there's no letter next to it, it has to go to the right hand side. Minus 15 becomes plus 15 on the other side over here. It becomes 4 plus 15 becomes 19. Alright, the 2b, remember, gets cancelled out, we don't need it anymore, and that there gets cancelled out as well, so all we're left with is 3b equals 19. Then this 3 here is b times 3, or 3b. So times 3 becomes divided by 3. 19 on the other side, divided by 3. Next bit over here. Now, I told you bed mass backwards, and think of the onion as the outer layer. Now the 5 is actually further away from the b. Believe it or not, there's actually brackets around this b plus 4, the invisible brackets, and brackets get done, well, for bed mass they get done first, but we're doing bed mass backwards because this is an equation. Alright, when you're doing equations, you do bed mass backwards. So ignore the addition because that's actually part of the brackets. Alright, that's all bracketed. There's invisible brackets around that. So brackets get done last. We do the divided by 5 here, becomes times 5 on the other side. So that's how we get 15 over there. And then b plus 4 equals 15, plus 4 becomes minus 4 on the other side, and it's just 11. That's your answer. Alright, now for something quite complicated here. What we need to do is think of a number that will get rid of all of these fractions, because fractions are horrible. We don't want fractions. It's difficult to deal with fractions with algebra. You're going to make everything really complicated if you try to do this and keep that fraction there. Alright, so what we can do in order to get rid of this fraction is we could multiply this by 3 and it would disappear, but multiplying this fraction by 3 as well, it would not help us very much. We need to multiply this fraction by 2 to get rid of it. Well, how about we multiply every single term, every single thing here by 6. Multiply that whole thing by 6, multiply that whole thing by 6, and multiply the 4 by 6. So every single term in this equation is multiplied by 6. So let's see what actually happens when we do that. If we multiply this here by 6, we're effectively multiplying by 3 and then multiplying by 2, which is the same as multiplying by 6. So multiplying by 3 gets rid of this division by 3. So that cancels out. And then you've got to multiply by 2 as well. So that 2 becomes 4. 2 times 2 is 4. Okay, so then you're left with 4c minus 3. Notice how it's much more simple now. Now what we've got over here, we've got to also multiply this one by 6 as well. So we can actually multiply by 2 and then multiply by 3, which is the same as multiplying by 6. Multiply by 2 cancels that out, multiply by 3 and we get 12 over here. Make sure you put the minus in there as well. And then obviously the 2 is cancelled out. But you've got to multiply this by 6 as well. So 24. 4 times 6, 24. Right? Now, I've left out a bit of a step here, but I'm sure you could figure out what's going on if you're smart enough to actually understand what we've done so far to get from that step to that step. It should be dead easy to do the rest of it. If you go back and have a look and see, there was something very similar here, wasn't there? Now, where was that other expansion thing? Oh, here it is here. Okay, 42. Number 42. Very, very similar now. If you look how you expand that, and if you expand that in the same way, and then you also simplify it. I've left out a little bit, I've done it all in one step here. I didn't have any space on there, but eventually once you expand that and then you simplify it as well, you should end up with negative 8c minus 36, and then obviously equals 24, and you can rearrange this as well. Your 36 goes onto that side, you get 60, and then you're going to divide by 8 to get, and there's actually a negative there as well, so you're going to have negative in the answer. Divide by 8, 60 divided by 8, and you get simplifies to 15 over 2, or 7.5, negative 7.5. Alright, next one over here, we've got number 58. Best way of explaining this is that we've got equals 0 here, and if anything is equal to 0, then if there's two factors involved, then one of those factors has to be 0. You would have to have 7 times 0 is 0, or 0 times 7 is 0, or 8 times 0 is 0, 26, 100 times 0 is 0, or 0 times 100 is 0. Whatever happens, one of the factors has to be 0 in order to make it to work. Alright, so this is in fact a factor here. X plus 1 is a factor, and x minus 3 is also a factor. If either of those factors, either x plus 1 is 0, or x minus 3 is in fact 0, then it's going to work. If we look at x is negative 1, then you could go negative 1 plus 1 gives us 0, and then 0 times whatever, it doesn't matter what it is, will give us 0. In the same way, if x is 3, 3 minus 3 is 0, and all of this here, x plus 1 times 0, will also give us 0. So in order to make this work, we could have x is equal to 1 or x is equal to 3. Next bit. We've got x squared plus 3x minus 4 is 0. A little bit more complicated. Well, first of all, we've got to try and make this similar to the two factors idea, equals 0. So factorize it. This is a good application for factorization. Alright, so looking for two numbers that multiply together to be negative 4, and add or subtract together to equal plus 3. So the ones that work are plus 4 and minus 1. Now you could have minus 1 and 4 as well, and that would work. Only in this case, don't reverse them when you've got something more complicated like this over here, because it does make a difference when there's 2x and x. But we've got x here and x here, so it won't make any difference whether you have x plus 4, x minus 1, or x minus 1, x plus 4. But just check that this plus 4 minus 1 does indeed give you plus 3, and the plus 4 times the minus 1 does indeed give you minus 4. And then of course the answers to this is, well, an easy way of looking at this is you could look at this plus 4 and you know the answer is minus 4 plus minus 1, and the answer is positive 1. Just change the sign. Easy way is just to change the sign. Same for this one over here, by the way. Plus 1, minus 1, or minus 3. Well, why didn't I tell you to begin with? You're probably thinking, well, I'm trying to teach people at least some kind of reason why behind it all to begin with. I wanted you to see why it works, and believe it or not, later on you can't do that. If it was a 2x in here, you wouldn't be able to do it, but it's just x and x. Well, simple, just change the sign to negative 4 and change the sign here. Minus 1 becomes positive 1. So negative 4 and 1. Alright, next bit over here. We've got best thing here is, if you can possibly do this, try to get this number over here so that you've got equals 0. Now you do that when you've got an x squared and another thing here of x, and then another number, whatever it is there. Okay, it's something that you can factorize. Don't factorize it yet though, because you want to factorize it once you get a 0 over here. So we want to be equal to 0. Okay, so what we want to do is move this 3 across to this side here, to the left hand side. When we move the 3, we'll be left with nothing, 0. but if you move the 3 across, you've got to do the opposite operation, which is minus 3. So minus 1 and then minus 3 will become minus 4. So that's where we get this minus 4 from, over here. Alright, next bit, factorising this. We've got two numbers that add together to give us negative 3 and multiply to give us negative 4. So we've got plus 1 and minus 4 will do the trick for us here. Notice that plus 1 minus 4 is actually negative 3, but around here plus 4 minus 1 is positive 3. Okay, so you've got to be careful, a little bit careful, right? So we've got over here, take the negation of this, a different thing. So plus 1 becomes minus 1, so x is minus 1, or the opposite of that one is plus 4, which is 4 by itself. X can be minus 1 or 4. Those are your answers there. Number 61. Where does this here, x squared plus 3x minus 4, intersect or cross the x-axis? So what happens when you cross the x-axis? That's going to be, now if this is actually going to, believe it or not, this is going to be a parabola. I'll show you some parabolas over here. Now these are parabolas, so you'll get to that later on. Okay, so notice that this is the x-axis over here, and this parabola has touched, hasn't crossed, but it's touched the x-axis at 0. This upside down parabola, looks like a frown here, has crossed the x-axis at negative 1.5 and 1.5, or around about there anyway. And this one over here is touched at 3. Okay, so what you can do is find out where they cross or touch the x-axis, and what happens in fact is you have to set the y value to 0, because this is like ground zero. Ground zero is the y altitude, the altitude is 0. Alright, so we're setting the y value to be 0, and that will give us the x value when the y value is in fact 0. Let's go back to our question that we have over here. We've got setting this here to 0, so y is changed for 0. Instead of y, we write down 0, and therefore we've got 0 equals this here. Alright, now if you factorise that, we've already actually factorised it, haven't we? We've got this one over here, number 59. We know that factorised when it was set to 0. It factorises and it gives us an answer of negative 4 and 1. So there we go, at negative 4 and 1. That's where it crosses the x-axis when y is set at 0. Give the next two terms for these ones here. So we've got number 62. 4 plus 3 plus, how much are we adding each time? 4 plus 5, sorry. 4 plus 5 to give us 9. 9 plus 5 to give us 14. We're adding 5 each time, so you just add the extra two numbers on there, adding 5. Alright, next one. It looks like we're subtracting 3. So we've got 11 minus 3 is 8, minus 3 is 5, minus 3 is 2, minus 3 is negative 1, minus another 3 is negative 4. A little bit of a complicated one here. We've got 5 plus 3 to give us 8, plus 6 to give us 14, plus 12 to give us 26. So plus 3, plus 6, plus 12. What's going on there? We're actually doubling what we're adding each time. So we've added 3, we've added 6, and we added 12. Well, we're going to add 24 next, aren't we? To give us 50, and then we're going to add 48 next to give us 98. Right? Add the double what you added last time. Okay, next one over here. Look at the pattern that we've got here. 2n, 3n, 4n, 5n. Well, next one's going to be 6n, and then you'll have 7n. And look at this other little bit separately. Plus 5, plus 8, plus 11. Looks like we're adding 3 each time, right? So 14 goes to plus 17, and then plus 20 is the next one, right? Okay, next question. Number 66. We've got Ralph takes 0.8 hours to clean out one of his chicken sheds if he has 40 chicken sheds altogether, and for each of green, white and blue ones which are already clean. So these coloured ones here, he's already cleaned them out, so this should be 12 of them altogether because there's 4 of each of these colours. So he's only got to clean 28. Alright, you could write this out in full, really, mind you. You know, sometimes you really have to. You might get away without actually writing that in, but 40 minus 12 here, we've got how much time it takes to clean out one of them, and then multiply it by how many there are that he still has to clean, 28, okay, which is this here as well, same thing. Mind you, be very careful here because it says write an equation and solve. Technically this is an equation. This is an equation. As long as you have a letter and an equals sign, it is technically an equation. So you've got to make sure that you write in a letter and something after, and an equals and then something after on the other side of the equation. No. If you just write down, okay, my answer is 22.4 hours. Nope. You won't get full marks for that. It's said to write an equation. Time is equal to 0.8 times 28, and then it works out to be 22.4. But you've got to write an equation as it says, just to keep to the rule and what it's asking you to do. And you'll find that they are useful in the future, even if you don't see much use for it right now. Ralph takes twice as long as Mark plus 7 extra minutes. If Ralph takes 48 minutes to clean a shed, how long does Mark take? Write an equation. Once again, write an equation. So Ralph is going to be set as equal to twice as much as Mark plus 7. 2 times Mark plus, or 2m plus 7. You could have written over here r equals 2m plus 7. Instead of 2m plus 7 equals r, but you're actually writing that's the same thing, okay? Now, there's a reason why I wrote the r at the end. You don't have to do that, but I wrote it at the end over here because I can swap this r with 48, okay? Because we know that r, in fact, Ralph takes 48. So r is 48. That's how long Ralph takes, 48. R is 48. Okay, so swap it for 48. Now we're only left with a single letter, and then we can solve it. Soon as you have a letter by itself, you can solve for that letter. So take the plus 7 over here and then move it onto the other side. It becomes minus 7, so it becomes 41. And you're left with 2m because the plus 7 is no longer there. So 2m equals 41. And so a single m is going to be 20.5. Just divide by 2. 20.5 minutes. Next bit, number 68. On each graph grid, draw a line of gradient m. Okay, gradient m equals 2. Now, this is effectively 2 over 1. There's another one here. Let's just go to this one just to try and explain to you what's going on here. We've got rise over run. Rise is how far up you go over how far across. Now, the default is 1. If there's nothing else there, it's actually over 1. So we're going up 2 and then across 1. So if you started here and did a little dot here for where you start, you can start anywhere you like on here. Okay, it doesn't matter where you start because you're just drawing a gradient, which is just a slope. It doesn't matter where you start. I'm going to choose to start here. I'm going to go up 2, and then I'm going to use the default of going across 1. This is like 2 over 1. Always think of it as over 1 when there's nothing else there. Okay, so across 1, up 2, across 1, default 1. Next bit. So m equals 2 over 3. So we're going to go, suppose we start here, choose to start here. We will go up 2, and we will go across 3. So 2 over 3 is up 2, across 3. And then you end up here, and then you join the 2 dots together. And you'll make a line there. Alright, what have we got? Next one over here. Hopefully we're working towards the end here. This is a negative gradient. So what it means is it's like a financial report going down. We're losing money going down. So make sure that your gradient goes downhill. Okay. Negative is bad. Losing money, negative financial report. Alright, so another way of looking at this as well is negative, put the negative onto that 4 there. So what we're going to do is first we're going to go down 4 and then across 5. So start here or anywhere you like as long as you've got space to go down 4. So you know you're starting here because you won't be able to go down 4, you'll go right off the grid. So let's try start at the top here, go down 4 and then go across 5. End here and then connect the 2 dots. So you've gone from there to there, connect the 2 dots together. Alright. Next one over here, use the following graph for the next 8 questions. So we've got point A is, now this is a little bit different. Now it's really important to explain this. Although we've got how far up or down over how far across here, our very first thing, yes, is going up and down and then across. Well, over here it's in the reverse order. You must remember and don't get confused by this. There's another confusing thing which is vectors as well, which we can cover later on, and that's going to be x on the top and y down the bottom. That's something we haven't covered yet. But this is gradient here is the y value over the x value, rise over run, but now we've got x and y here in a different order. So x to begin with. So how far are we to get to that point of A there? Well, if we started at 0, we have to go across -1, go across first, and then we go up 1. So across -1 to go backwards, and up 1. Point B. Let's look at point B. Start at 0, we go across 1 and down 1. Will give us 1 and then -1 to go down 1. Point C. Well, where's point C? Point C is there. So we're going to go across 0. From 0, you don't even move at all. You go across 0, and then you go up 3, and that's point C there. Okay. Next one here. Point D is going across 3 and 1. Point D, well, let's just prove this to you anyway, even if you didn't, suppose you didn't have the answer, you've got to try and figure it out. That's sort of the question was to try and figure it out. So we can see that D is there. Starting at 0, we've got to get to D. We've got to go across 3, so you get the 3 there, and then up 1. Alright, and then you get to D, so you got 3 and then 1. Okay, equations. So a lot of people might not understand this. I'm hoping you can figure it out now if you don't understand it yet, so here's your chance. Okay, so we've got the gradient or the m stuff that we've already done over here, and then we've got something else that occurs called the y-intercept. Now, start with the gradient. If we start, we're looking at AC. So AC is that number 75 there. AC is this line here. Gradient, m value. Well, this is rise going up 2 and then across 1. So 2 over 1. But that actually simplifies to a 2, doesn't it? 2 divided by 1, 2 over 1 is just 2. So that's where we get this 2x from. How do we get the plus 3? Well, it crosses the y-axis at 3. So you must write down plus 3 after that. Let's look at the next one. Next one is AB. Let's look at AB. So we're going from A to B. So A is, let's see if we go up or down to begin with. We've got to get the gradient, remember, so the m value to begin with. So we're going to go up or down. So I think to go from A to B, we've got to go down. Down 2, and then over 2 more. So 2, or -2 in fact, because we're going down, -2 over 2. That can simplify to -1. Alright, -2 over 2 can simplify to -1. So we've got -1x, which is in fact just -x. Y equals -1x, just -x. And there's nothing else there because the reason is because it's crossing the y-axis at 0. So we could write down plus 0 at the end of that, but it wouldn't make any difference. In fact, don't do it because You shouldn't write down extra things that you don't need in algebra here. So plus 0, we just leave it out. Let's look at the next one, CD. So going from C to D, we're going down 2, so it's going to be negative 2 over 3, across 3. So negative 2 over 3. And you have to follow it by an x. So this is where we get this here. Negative 2 over 3x. And then CD crosses the y-axis at 3. So that's where we get this plus 3 from, just here. Okay, last one, BD. BD. So we're going from B up 2. So go positive 2 over across 2. Alright, so 2 over 2, which is in fact 1. So up 2 and then across 2, so it's 2 over 2 as a fraction. That can be simplified to 1. So what we've got is we're going to have 1x, so it's where we get this here, 1x, or just x by itself, leave out the 1 in algebra, 1 next to the x, and you'll leave out the 1. How did we get the negative 2? Well, let's have a look. Well, the final number that you need is where it crosses the y-axis. Now if I extended that line, that BD line, all the way down here, in fact it would go through the point, it would go through negative 2 on the y-axis. That is the y-axis there, by the way. The vertical is the y-axis, and even though it's not written in there, x is the horizontal axis there. But if I extended that down, we would definitely get to negative 2. Alright, hence that's where it crosses the y-axis, the y-intercept, that's what it's called, negative 2. So that's why we've got negative 2 there, minus 2. Alright, now next one, fill in the table. Hexagon. Now this is a hexagon, 6 matches to make up a hexagon. So if we start with one hexagon, we end up with 6 matches to make this hexagon. Alright, so that's the number of matches that you need, match 6. Okay, we add an extra hexagon to this. We actually don't need 6 more. We only need 5 more because we're using one of the matches that are already there. So we had 6 and we added 5 more to get our second hexagon there, and we ended up with 11. Alright, so notice that to add another hexagon, we're going to add another 5 more, and so on. Alright, so that's how we get 3 hexagons is going to be 16. Now how did we get this? Well, leave it out. Just leave it out to begin with. Don't even bother doing that yet. You need the formula. So what we need is to try and work out a formula here. Now we're given that it's going to be t equals something. Okay, the formula that we need in order to work out the number of matches t used when we're given a number of hexagons, which is n. N is the pattern number, the number of hexagons, and t will tell us how many matches we need for that number of hexagons. Alright, so let's have a look. So what you have to do is always, just the easiest way to remember this, how much are we adding each time? We're adding 5. Start with a 5 in the formula. Alright, so 5n. Don't make the mistake and go plus 5. Don't do that. A lot of people do that and it just does not work. If you test it out and see whether it actually gives you the correct answer, it doesn't. People might think that, well, we're not. Well, we are adding 5 each time, but in fact we're adding multiples of 5 here. We're adding 1 5 to get to 11, but to get to 16 we're adding 2 5s. And the next one after that, with 4 hexagons, we'll be adding 3 5s. So we're actually multiplying, doing a multiple of 5 each time. So we're actually multiplying 5, even though we're adding 5 each time, in the formula we're actually multiplying. If you don't understand that, just memorize it. How much are we adding each time? You've got to have that number times n, or that number n. Adding 5 each time, 5n is what you need. How did we get that plus 1? Well, we'll get to that over here. Well, if we did 5n when n is 1, 5 times 1 would give you 5, and we need another one because we haven't got 5 matches, we've got 6 matches, we need an extra one. Alright, So that's where we've got that plus 1 in there. We needed to have extra 1 just to make it work properly for us. So when n is 1, 5 times 1 is 5 plus 1 gives you 6 matches. When n is 2, let's have a look. Let's just check, because it's good to just check if everything works. You need to check and make sure you don't make any mistakes. So n is 2. Hopefully you get 11. Well, let's have a look at the formula and see if it works for us. So 5 times 2 is going to be 10 plus 1 is 11. So it works. Alright. When n is 3, we should be getting 16. So let's just check if that works. 5 times 3 will give us 15 plus 1, 16. Alright, so we've got 16. By the way, just remember, don't always think that this is going to be a plus. Sometimes it's a minus. It could be a minus 2, a plus 3, minus 7, plus 18, minus 18, minus 17. Could be anything. That you just got to choose a number that actually makes the formula work. In this case, we needed one more to make it work. Alright, so now what we can do is practically put this to use. So we can use the formula to work out this 501 here. So suppose you didn't know 501 was the answer. Well, we know that we're going to use 5n plus 1 as our formula, aren't we? So if we started with 100 hexagons, well, 100, 5 times 100 for our n will give us 500, plus 1 will give us 501. So that's our answer there. That's what we've got. Okay, next bit over here, fill in the tables for the rules below. Now I just want to let you know that parabolas are drawn when we have x squared. If there's an x squared in there, or even over here we've got a squared, when that happens we have what's called parabolas. We don't have time to explain why they have a shape, but they are a strong shape and used in lots of cases in constructing bridges. You could think of an extended wider, a couple of wider ones of these type of parabolas that were used for the construction of a Golden Gate Bridge. Also sometimes tunnels are a parabola shape. You think of a railway bridge that goes over a chasm, a deep trench or something like that, where and the train goes over the top here, an upside down parabola. In fact, this gets hooked to one side of the cliff, and then the other part of the thing to the other side of the cliff, and you can create a railway bridge using this kind of shape. Alright, so they have applications in real life. It's not just all numbers. Okay, people use them in construction. Alright, you might want to know, well, how much metal we need to produce. Well, you're going to have to use parabolas and figure out how much metal you will need and the length of the metal in order to produce this parabola here. In that case you would use algebra. So it does have its applications in real life. Let's have a look at this here though. Okay, so y equals x squared. Suppose we start with x squared. Now when x is minus 3, if we square that number including the negative, negative 3 times negative 3, it's going to be a positive. It's going to be positive 9. So that's where we get positive 9 here. If we take negative 2, when x is negative 2, we've got negative 2 squared, including the negative as well. You're going to have positive negative 2 times negative 2. Two negatives cancel, give you positive 4, and so on. So negative 1 squared is 1, and all of these 3 squared is 3, etc., etc. Notice that there's a pattern here, by the way. It's symmetrical. That's why the parabola is symmetrical on both sides. The negatives actually become positive, so it means even though you've got negatives on the x-axis back there, in fact it still goes up on the y-axis, because the two negatives are multiplied together and they give you a positive y value. Alright, over here, notice the symmetry here as well. So negative 5, negative 4, negative 1, 4. So notice here negative 4, negative 1, 4, symmetrical on both sides as well, and with negative 5 as vertex, the lowest point. Alright, and notice that negative 5 is in fact the lowest point. If you know how to draw parabolas, that's an easy way of drawing it. But look, if you don't want to do it that way, let's just do it by figuring it out by putting in these x values and working out what the y value should be, corresponding y value. So negative 3 squared is negative 3 times negative 3, which will give you positive 9, minus 5 will give you 4. So y value is 4. And we'll try another one here. So we've got negative 2, you've got to square it, so it's going to be positive 4. Minus 5 gives you minus 1. Okay, so etc, etc, so you can figure out what they are, in fact, there. Okay, another one over here, let's have a look at this one. Negative x squared. In fact, this is our negative parabola, by the way. It's an upside down parabola. Which one's different? Well, notice this one here, upside down parabola. Well, that comes from this this negative here, negative right there. Alright, once again, you don't need to know how to do this. You don't know how to draw it. You can't remember how to draw it. Just simply put in the values of x values and put it into the equation, see what you come out as the y values, and plot the points later on. Okay, so what we're going to do is make the table up here first, and later on for the last question we're going to try and plot the points and draw a line of best fit. Okay, let's get the points here correct first. Negative 3 for x, and then we're going to have we have to square this first, so negative 3, because you've got to do powers first, remember, bed mass, don't get mixed up, we're not rearranging an equation here, we're not moving something from the other side of the equation to another side, so we're not using bed mass backwards, we're simply evaluating and plugging in values here into the formula. You use standard bed mass, and standard bed mass you've got to do exponents first. Alright, there's no brackets, so we leave out that. Exponents first over squareds. So you take this negative 3 times the negative 3, which is squared. Negative 3 times negative 3 will give you positive 9, but then you've got to put a negative on that, which is the second step. Alright, so you have negative 9, and then you've got to go plus 2, will give you negative 7. Alright, let's look at another one here. We've got negative 2 for the x value times negative 2 when you square it will give you positive 4. Then you put the negative onto that, you get negative 4, and then plus 2 will give you minus 2. Okay, and so forth. Hopefully you can go through all of these other x values here and see what you get for your other things. But notice that it's symmetrical again. We've got a vertex at, where's our vertex here? 2, 1. Oh yes, vertex is the highest value in this case because this is an upside down parabola, remember. So our highest value, our maximum, will be 2. Alright, and notice it, that's a 2 there. See, vertex is 2. Everything else is lower. Alright, we've got another last one here. Once you've got all those values, you can plot them in later on. Okay, but let's look at our last one here. So when x is negative 3, negative 3 minus 3 will give you minus 6. Square that, and you'll get positive, because negative 3 times negative 3, positive number, positive 36. In the same way, you've got minus 2 times minus 2 and then minus 3. Another 3 gives you minus 5. You square that and you get positive 25. And then the other one here, so forth. Okay, so minus 1, minus 3, so minus 4, square it, and you get positive 16. And here we go. Last bit is to plot these points here. Okay, so you can do them one by one. For this one here, y equals x squared. Well, we've got negative 3 across and then 9 up for the y-axis. So start at 0, go negative 3 across, and then go up 9 to get to this point here. Plot the point. I've drawn it in. Well, it's been drawn in by a computer program here automatically, but if you plot that point there, negative 3 across and positive 9 up, and you just put that little point in there, and you leave a point as it is, and you do another point. Let's have a look. So we've got negative 2 and 4. So we go across negative 2 and then up 4. So do another point there. Okay, right there. Then we'll do another point. We've got negative 1 and 1. So negative 1 across and then 1 up. So -1 that way, and then 1 up will give you this point here, and so on. So as you can see, eventually you'll be able to have all the points on this parabola line, and you try and draw a smooth line through those points all the way to the edges of the display. All right. Same thing for all of these other values here, for these other ones, for these other equations. Make sure you label them clearly. This one here is y equals x squared, so it's been labeled very clearly on there. This one here is y equals, in brackets, x minus 3 and then squared. Notice that this one here in fact had a few really high numbers, so have a look here. We've got and you can see it's not symmetrical either. That's because, well, it is symmetrical, but the symmetrical part as you goes way off the scale over here as well. If we extended this in the x direction, we've got symmetry. It will continue to go up, but we didn't do that, right? Okay, and in the same way also we've got -3 gives us the y value of 36. Now that's way off the scale in the y direction as well. If I went -3 across here and all the way up 36, well, it's way off the page, way up there, so you can't plot that point. You just leave it out. Okay, leave it out. You can't plot the other point either. You can't go -2 and 25, and you can't also you can't do -1 and 16 either. So 16's way off the scale here. It's off 10. So what you will do is just do the ones that you can. 0 and 9. Across 0 and then up 9. Across 1 and then up 4. So across 1 and then up 4 is another point there. And the other one that you can do is, well, there's two of them. 2 and 1. So across 2 and then 1. Across, oops, what's happened here? Something's frozen here. I don't know what's going on there. Anyway, something's bug in the system. Anyway, cross 3 up 1. What was it originally? So I think my whole thing's frozen. We've got some problem with the software here. Anyway, I better just quit here, but what you do is you just make sure everything's drawn in, and you then draw a line of best fit going all the way to the edges there. Alright, so I'll just stop it there.